Our third and final story today is we're carrying on a southerly trajectory. We're heading further south. We're heading to the area near Dunedin, and we're heading to hear a story from a school. Again, this was one of the stories that we heard in the regional user conferences we hold in the March, April time. And we thought it was such a fantastic story. We really wanted Simon to come up and talk to us about it. So Simon is the head of science. He's not a geography teacher, he's a science teacher at Kaikorai Valley College in Dunedin. And they've been using ArcGIS online and apps to teach their students there about ArcGIS, but not just about ArcGIS, about using it as a teaching tool for other subjects. But also what's interesting for me is what they've actually learned as an organisation through using GIS. So please welcome to the stage our final customer story today, Simon McMillan.
Tēnā koutou, tēnā koutou, tēnā koutou katoa. Greetings to you all. And thank you, Scott, for that introduction. And thanks too to Eagle Technology for their support of our school and schools everywhere in New Zealand. Today I'd like to outline to you our learning pathway as we embrace ArcGIS online in and outside the classroom in the context of a school project. An important area for you to focus on is in the context for using GIS and the links we have and are making to experts in our community. So we're beginning our learning pathway, and our goals are to apply, of course, GIS in the classrooms, but one of the things is to eventually become a centre for GIS foundation learning for students to transit from directly from school into the workplace or to tertiary study. This is a map that I like, and I just want to introduce it to you a wee bit. Last year I spent 4 months at Indiana University in the USA on our Fulbright Teacher Award. I was very fortunate to do that, and during that time I was challenged along with 20 other teachers from around the world to change our thinking about how we approach learning in primary and secondary schools. If you like, I was asked to challenge to turn our thinking upside down and focus on implementing more informed teaching approaches based on inquiry, and particularly student-centeredness, collaboration, and in my part, explicit teaching of metacognitive development and critical thinking. And GIS, of course, is tailor-made for all of this, and this map gets me thinking every time I see it about turning what I'm doing in the classrooms upside down, giving it a good shake and seeing what comes out in a different form. Now, I just want to point out the map, of course, because this is New Zealand in its rightful place, isn't it? It's at the top of the world and it's in the centre. And if you could just bear with me for a moment, can I say that Dunedin, my city, is now above Auckland on that map. I want to just frame for you a wee bit now the context for the GIS that's coming at you shortly. And first of all, the government has an initiative called the Investing in Educational Success, and some of you may have heard of that. It gives teachers the chance to work within and across schools to improve learning outcomes for students. And our school applied and was successful with 2 grants to what was called the Teacher-Led Innovation Fund, and that's part of IES, but it's separate from it. The IES package also involves something you may have heard about called Community of Schools, or COLS. So this grant that we were given for this project is shown on the screen, and I just put it there to let you know that's the type of funding that is available for schools to engage with collaboration with experts in the community, and it was definitely to our benefit to have made that application, and I hope that you will see that shortly. Now, our project was to develop an urban farm on our school grounds in partnership with 4 local primary schools, and the project's goal was, underpinning everything, was to improve students' ability to think critically about their world, and we had a science and technology and sustainable agriculture theme. So here are a couple of aspects of the farm. At the top left-hand side, you can see a map outline of what we are proposing in the space, and we've achieved some of those already, but we've got more work to do. I want to point out the young people in top right of your display. We've got 3 young people here who were involved in the Young Enterprise Scheme in 2015, and they won 3 national awards for what they developed on the farm site. It was one of our first activities. It's a biogas production unit And you might be able to see just behind Regan here, there's a dome that captures the biogas that they produced a business plan for and then implemented it in the school. And Regan there is pouring some effluent from that bucket and is going into a PET bottle. They used that to sell as fertiliser around the local community, and they did very well with that. The Young Enterprise Scheme is something that we are really keen on trying to promote with what we're doing because it involves business and getting students to think about business plans as well as other types of learning. The students collected local food scraps from supermarkets, and they macerated it in a large blender, and then they fed it into essentially a large plastic bag behind the young man there. And we had some microbes already inserted in that bag with some horse manure and plenty of it. So away things went, and we were certainly able to cook our sausages on the gas that was produced and our pikelets, and that was, of course, engaging for the students. And maybe just I think we've got a wee bit more time, but just tell you what our plan is for the methane gas that's coming off there, and the fence that you can see just to the left-hand side here of Sophia's head. We're planning to feed that gas into a generator to provide heat and put that into a glass house just next door to that fence. And the CO2 that produced, we're going to put into the glass as well to saturate the environment. And then when the plants die, we're going to put them back into the biodigester. And this is a real focus for us on terms of sustainable thinking in circular systems rather than linear resource systems. So a great collaboration here and a lot of inquiry came out of this work. You can see the students here on the bottom right-hand side collaborating together, so primary school students with secondary school students and our teachers. And you can see a practical application here for learning about electrical circuits rather than being in your classroom trying to put up an electric fence, which is certainly interesting and full of safety hazards, so it has to be done the right way. I just want to move on then to talk about the GIS and what students did. They collected data in their farm space to produce maps that would help them make decisions about where the activities they wanted to set up should be on the farm. So this was a student-driven project, and for teachers this can be hard to take because you've got to step back and let the students get on with the business of driving their own learning. So we decided to get them out collecting some climate data, and the young girl standing here in the foreground is holding up a device, it's a Kestrel type device that measures, for example, air temperature, etc. And the little girl just standing behind here she has a smartphone, and it's a Vodafone smartphone. We decided to buy a suite of about 12 generic Vodafone smartphones to locate us in our space, and we did that because the wireless didn't work that well, and we found that the cell network seemed to locate us more accurately in terms of our data points. So these students were around about 8 to 10 years of age, so they're quite young, and we were collecting that data on the smartphone with Collector app. The students went and they stood on a 20 by 20 metre grid to collect the data, and they were accompanied by parents as well and teachers to try and ensure that they did the right thing and stood in the right spot. However, we had some issues. And here's our map, and it looks a wee bit like the measles, and except that we do have some nice tight clusters in several places, and of course here's a nice one here. But this got us, this was wind speed, and this got us talking about all sorts of things to do with data. And I think it's really important at an early age to understand the difference between good quality data and data that's pretty poor. And so we had a larger discussion here about that. And of course, we didn't put our students in the middle of this main road here either, and we didn't put them in the bushes here. So it was a good discussion that we had. Just taking things a bit further, we've also been supported by different experts from outside the school, and here's one: Geological and Nuclear Sciences have been giving us a hand. This magic wand that you can see away here to the right-hand side is a portable X-ray fluorescent machine, and it analyses chemical elements from the soil. And we have the GNS in Dunedin doing a citywide research project looking at the elemental composition of soils. And so they decided to come out and have a look at our area, and that benefited us because we found out that we had certain concentrations of this element or that element that were useful to know for reasons of, say, fertilisers or contamination or, for example, having animals in certain places. So this is the data that came from that. And so this is not our data, this is Simon's data, but we're going to be using this as we go forward with our students. And this is just an example of, for the element calcium, the different concentrations in parts per million around the site. And you can see that there's some variation there in the amount of calcium that's present. And it seems to be concentrated, by the way, towards the back where the country rock is full of calcium carbonate. So here we have again the experts coming into our project and being involved with us, and the scope is there for developing that further in the future. Okay, well, future directions and where we're going to go. One of them is to focus on teacher and student GIS PLD together as a group, working collaboratively and building the capability within our teaching and student cohort. And shortly you're going to see a video on that. And we're also looking to use GIS data for geography students to meet requirements of NCA Level 2 and 3, and you may know that there are some achievement standards at those levels that focus on spatial analysis, and we would like to use Simon's GNS data on soils for that purpose. So just in a moment we're going to go through and have a look at the video, but can I just say something? It was taken in the snow on July 13th, and unfortunately we had about 10 people who weren't able to turn up to the event, and it turned out that our GIS team of girls weren't able to turn up, so there's a gender bias on the video, but it's not intentional at all. We're using GIS. We're a beginning school trying to get upskilled ourselves in terms of being able to use GIS with our students as a teaching tool, looking at improving their problem solving as well as giving them better future prospects in terms of careers. We feel that GIS is a developing area that our students really have to engage with and have a chance to at least explore, and we are really keen for them to do that. We've brought teachers with students together and some experts from the University of Otago and GNS Science, and we've looked at collecting some data with a smartphone and manipulating that on an online map, and then looking at story maps as well and other issues to do with GIS.
It's just data, so digital data, but the key thing is that for any bit of data we have location attached to it. So it's being able to take a measurement, whether it might be air temperature or population or rainfall, and knowing where that measurement came from. And once we do that, we can display that data geographically, we can analyse it geographically. So it's the spatial or the geographical location that's the key.
The model that we wanted to use with our school as we develop strength and capability here to employ GIS is to build a critical mass of people that are going to know and understand the different ins and outs of using the tool. So our model is to involve teachers learning at the same time with experts from outside and with students involved in the learning group.
I really like the students to see that we're all learning all the time. It's really cool to be able to share that love of learning with the younger students and also make them realise that new things are happening all the time that we need to learn. So it's not just a one-way process.
I think it's really quite a good experience, like just getting to know your teachers and know what they know, and just so you both are on the same page and know the same things.
Teaching science, I love to incorporate as much new technology as possible. I like inspiring the students to think about the way the world works around them, but incorporating the new ways as well as the old ways of doing things. So any new technologies I welcome into the classroom.
I like this technology because it's quite fun to use, and it is applicable in many different ways and fields.
You can go to certain areas, specifically the area you want to be collecting data in. You can collect data using a number of tools and just input the data on the spot through a mobile phone, and then you can just edit the data and get what you want out of it straight from a computer as soon as you want after it.
We started off with about 50 schools. At the start of the year, we're now probably up to about 100 schools, variety of levels, so primary and secondary school doing GIS. A lot of it in the geography curriculum because they have the standards to be able to slot GIS in, but looking more at sort of really small ways of putting an interactive map about, malaria into a subject is also a way that some teachers have been using GIS in the classroom.
For the future, I reckon it will be used quite a lot, and especially also on other planets and whatnot. Yeah, I'm planning to be something with the ocean, so I can use it for mapping the ocean. And, yeah.
So our idea about teaching science is changing, and it's really important that we do that. We're moving from that way of teaching that's just giving information to students and making sure that they know it, maybe memorise it, to shift that to understanding the information they're given. And GIS is a way of doing that because they have to apply the knowledge that they are finding on this parameter or that parameter to solve problems that they can even pose themselves. And so that's a powerful tool and a powerful new direction that science needs to go, and I think GIS is giving us the capability to do that. Okay, thank you. We're almost there. This is just a summary then of success to date, and one of the first things is committed leadership, of having someone who's there to keep on pushing what's required in a school. It's really important. There are lots of competing interests to school life, and you've got to have someone there pushing and pushing to make things happen. Enduring partnerships, treating people with sincerity is a key element of what we're trying to do, because we need their support and we want to try and give them something back with the support that we give from them. I'd like to thank the organisations and different people who have helped us. We've had great help from the Surveying Department at the University of Otago and Eagle, of course, the Ministry of Education, and also people like Core Education as well in our project. The other success that I think we really need to emphasise is the innovative type of approach we've tried to do with everything that we've approached in our urban farm project. And I just want to point out these 4 students here. They're the Young Enterprise Scheme winners from last year, and they also won 2 national awards for an urban farm project where they built beehives for the rural residential market. I don't know whether you are in that market, but it's kind of hard to get beehives if you want them. And they were able to produce it, and they sold many around the South Island as part of their business plan. And they also had a line in recyclable wood as well for those beehives. So we'll just end it there. Ladies and gentlemen, I've really enjoyed being with you this morning, and I'm more than happy to answer any of your questions maybe afterwards, and thank you very much for having me.
Thank you very much, Simon. Thank you very much. Excellent presentation, and I think 2 things to note. One was they breed them tough down south. You notice the 8-year-old in the shorts in the snow. Yep. And also it was good to see my future interns a couple of years ahead, so that's great. Thanks, Simon. Another thing that Simon spoke about there was the partnership aspect, and for me that's a key part of everything that we do as a community, partnering with ourselves, partnering with the Open University, Otago University, partnering with GNS and others, and the learnings that have come from those partnerships are really key.